Hello everyone. So this is our first day of our new unit technically. We're still in trigonometry, but this unit focuses a lot more on graphing, and so everything you know about sine, cosine, tan before is now going to turn into a different type of visual representation. Like how do we graph these functions? And the brand new word that we're learning today is what is a periodic function? So there's some dot dots here. I'll read them out for you in case you can't read my writing. And you can pause it if you want to write it down as well in your notes. But basically, a periodic function is a function that produces a graph that has a regular repeating pattern over a constant interval. And we'll see a couple of examples in a second to kind of make sense of that, but that is important, that it repeats in the same pattern over and over again. So it describes something that happens in a cycle, can't just happen a couple of times, it usually happens over and over and over again, repeating in the same way. So what are some examples? Let's take a look. So one example that you often see in textbooks is of a pendulum on a clock. So let's write that down here, pendulum of a clock. So it moves in a regular repeating pattern. There's a center, it moves to the edge, it comes back to the middle, and then goes to the other side, and back and forth forever. And it repeats in the exact same way. It'll always come to a certain distance on one side and the same distance on the other side, which is important. So it does check off what we need it to. Another example is a Ferris wheel. So it has a lowest height, it has a highest height, and it will always stay in between those 2 points, and it goes around at the same speed that it comes back down at, and then it goes around again at the same speed that it comes back down at. And that is important. That is a regular repeating motion and is very often represented by a periodic function. You will definitely see those later on in this unit, the Ferris wheel example. I guess you have to ignore the fact that sometimes Ferris wheels do kind of have that stopping to let people on and off, but when it's actually in motion, it is a regular repeating pattern. So we will add that here, a Ferris wheel. And our last example for today, there will be many more in the future. This is high tide versus low tide. I guess in the picture it's actually the opposite. Our low tide's over here and our high tide is over here. And this actually is an example from Nova Scotia, or no, somewhere on the East Coast, the Hopewell Rocks. Newfoundland? I don't remember. So this here is our low tide where there's no water, and then throughout certain times, a certain period of time, it will get more water, and then at the end it reaches its maximum, the high tide. So it has a lowest and it has a highest, and it repeats in a pattern, and it can also often be modeled by a periodic function. So these examples are great and all, but what does that mean if we put it onto a graph on an XY axis? So here's an example of a function that would be a regular and repeating pattern. And so there are some words that we need to define and be able to point out and recognize. So we know this is a cycle, and we know that one cycle is the smallest complete repeating pattern of a graph. So the first word is period, and this word is the length of one complete cycle. So we're going to look at this graph and we're going to say, okay, well, it repeats. How long is this repeating pattern? And we can pick any part of it as long as it starts and ends in the exact same spot. So I can start from here, let's say, and I know it goes up, down, and back. And how long did that take to get from here to here? So in this case, our example, it is 3. Our period is 3. We don't have units here, so usually you would have 3 seconds, 3 hours, 3 days, 3 meters, depending on the situation. But here we just have 3, no units. And we know that this is a periodic function because every single cycle has to be the same. So from here to here is 3, and here to here is 3, and here to here is 3. So that's good. We know that it's periodic. So our period, the length of that one cycle, is 3 units. Okay, so another word that we have to talk about is the amplitude. And the amplitude is the height from the middle of your graph, the center, from the top or to the bottom. And a way that you can calculate that, the amplitude, which is usually represented by the letter A, is you find the max, or the highest point on your periodic function, subtract the minimum, and divide it by 2. And oftentimes you can really just find this visually. You don't need to rely on a formula, but it is helpful to understand that as well. So our highest point here, our max is 3, and our minimum here goes to -1. So that's kind of our max and our min, kind of like the max and min height of the Ferris wheel, or the max left and max right on that pendulum. So 3 subtract -1 divided by 2, which will give us 3 plus 1, which is 4 over 2. So 2, we have a length of 2 from the center to the top or the center to the bottom, but we need to find that center. So another word for that center line is called the equation of the axis. And it's like a horizontal, invisible, horizontal dotted line that cuts through the middle of your graph. And it can also be represented, it is an equation, right? So we're going to say it's y equals, because it's a horizontal line, max plus min divided by 2. So it's kind of like you're finding the average of that max and min. And we've already found those values. So 3 plus -1 divided by 2, which is 2 divided by 2, which is 1. So our equation is y equals 1, and let's put that on our graph. Maybe I'll put it in green. So here, now you can visually see that, you know what, that does make sense. It looks like exactly in the middle of the graph. And we have our amplitude that goes, we said the amplitude was a length of 2. So from the center up to the highest point is a length of 2. And from that center down to the lowest point is also a length of 2. So we know that this is the correct equation of the axis because it cuts your periodic graph right in half, and it has the same distance up to the highest point as it does to the lowest point. Another way that you might see this written as, you might hear it be said as, is the midline. I definitely prefer equation of the axis, but it doesn't really matter as long as you understand. And you will definitely need to know how to find that value easily because you will use it when you do graphing in a couple of days. So hopefully these words make a little more sense. They are brand new words. You should definitely write them down and start to use them and identify them through the practice questions. But I have a few practice questions of my own, so you should pause the video here, take a look at this graph, figure out the period, amplitude, and equation of the axis. And the same thing you should do for example 3. You should pause this. Again, this is like a more irregular shape. In example 2, that's one that you're definitely going to see in the next couple of days. Represents a sine or a cos graph, you'll see. And number 7, is just an irregular pattern, but is it repeating? Does it have a period? That's up to you to figure out, and I will post the answers in our calendar. So good luck.